Hello everyone, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today in this video, I am going to talk about symmetry and group theory. You know, my friends, the symmetry properties of molecule and how they can be used to predict the vibrational spectra, hybridization and optical activity. So, point groups. First, we will learn about point groups. So, what is point group? You know, molecules are classified and grouped based on their symmetry. Molecules with similar symmetry are but into the same point group. A point group contains all objects that have the same symmetry elements. So, what is symmetry element? Symmetry elements are mirror plane, axis of rotation, center of inversion. So, a molecule has a given symmetry element if the operation leaves the molecule appearing as if nothing has changed, even though atoms and bonds may have been moved. So, here symmetry elements, you know, element n-fold axis, mirror plane, center of inversion, n-fold axis of improper rotation. So, identity symbol E, rotations by 2 pi by n, symbol Cn, reflections sigma, inversion I. So, rotations by 2 pi by n followed by reflections perpendicular to the axis of rotation Sn. Now, n-fold axis of rotations. If you have the ammonia, you know ammonia has a C3 axis. Note that there are two operations associated with the C3 axis. Rotation by 120 degree in a clockwise or a counterclockwise direction provide two different orientation of the molecule. Now, n-fold rotation. Water has a two-fold axis of rotation. When rotated by 180 degree, the hydrogen atom trade place, but the molecules will look exactly the same. You can see here. So, mirror plane. What is the mirror plane? So, the reflection of the water molecule in either of its two mirror planes results in a molecule that looks unchanged. So, you have sigma V and sigma V prime mirror plane. The subscript V in sigma V indicates a vertical plane of symmetry. This indicates that the mirror plane includes the principal axis of rotation. The benzene ring has a C6 axis as its principal axis of rotation. The molecule plane is perpendicular to the C6 axis and is designated as a horizontal plane sigma h. So, the vertical plane go through the carbon atom and include the C6 axis. The plane that bisect the bonds are called dihedral plane sigma 2. Now friends, inversion. What is the inversion? The inversion's operation projects each atom through the center of inversion and across to the other side of the molecule. You can see the inversion in this molecule. Improper rotation. An improper rotation is rotation followed by reflection. Rotation followed by reflection in the plane perpendicular to the axis of rotations. So, you can see A, B, C, D and C4 and sigma H horizontal plane is there. So, first rotation and then reflection. C4 is rotation and sigma H is reflection. So, improper rotations, the staggered conformation of ethane has an S6 axis that goes through both carbon atom. Now, note that an S1 axis doesn't exist. It is same as the mirror plane. So, likewise, an S2 axis is a center of inversions. Now, point group, molecules with the same symmetry elements are placed into point groups. So, point group, water and ammonia both belongs to CNV class of molecules, and these have the vertical plane of reflection, but no horizontal plane. So, water has only vertical plane and ammonia also have only vertical plane. Now, DNH groups have horizontal plane in addition to the vertical plane. Many inorganic complexes belong to these symmetry groups. So, this is the D4H and it has the horizontal plane. Now, highly symmetrical molecules such as identically substituted tetrahedron or octahedron belong to their own point group, tetrahedral and octahedral respectively. In assigning a point group, we typically ignore the fine details such as conformation isomer of the ligands. In working problem using group theory, the point group of molecules will usually be provided to you. Now, character table. You know, the symmetry properties of each point group are summarized on a character table. The character table lists all of symmetry elements of the groups along with a complete set of irreducible representation. So, this is the one table and that is the character tables of C2V. Point group level, green one. Symmetry operation, the order in the total number of operations. A1, A2, B1, B2, symmetry representation level. And then you can see in yellow representations of B. Then you can see the character in C2V, the order is 4 because 1E, 1C2, 1 sigma V, 1 sigma V prime. So EC2, sigma V, XZ, sigma V, YZ. What is XZ and YZ? This is the plane. And plane always in 2 dimensions, so XZ and YZ. So A1, A2, B1, B2. So A means symmetry with regard to rotation about the principal axis, A1. B means antisymmetric with regard to rotation about the principal axis. So subscript number are used to differentiate symmetry level if necessary. One indicates that operation leave the functions unchanged, it is called symmetric. -1 indicates the operation reverses the functions, it is called antisymmetric. Now friends, C2V, A1, A2, B1, B2, EC2, sigma V, XZ, sigma V prime, YZ. So symmetry functions, you can see the Z, X square, Y square, Z, this is Raman, RZ for A2, X and RY for B1, and Y, Rx for B2, and XY, XZ, YZ, that is the functions. So the function to the right are called basis functions. In yellow, it is basis function. They represent the mathematical functions such as orbitals, rotations. So the px orbital, you can see sigma V and C2, chi -1, chi -1. If a px orbital on the central atom of a molecule with C2V symmetry is rotation about the C2 axis, the orbital is reversed, so the character will be -1. The px orbital on the center of atom of molecule with C2V symmetry is rotation about the C2 axis, the orbital is reversed, so the character will be -1. Now, if a px orbital on central atom of a molecule with C2V symmetry is reflected in the YZ plane, the orbital is also reversed and the character will be -1. The px orbital. If a px orbital on the central atom of a molecule with C2V symmetry is reflected in YZ plane, the orbital is also reversed and character will be -1. Now, if a px orbital on central atom of a molecule with C2V symmetry is reflected in the XZ plane, the orbital is unchanged, so character is +1. So, character table representations, how you will understand properly. Characters of +1 indicate that basis function is unchanged by the symmetry operation. Character of -1 indicate the basis function is reversed by symmetry operation. Character of 0 indicate the basis functions undergo a more complicated change. So A represent indicate the functions are symmetric with respect to rotation about the principal axis of rotation. B representation are asymmetric with respect to rotation about the principal axis. E representation are doubly degenerate and T representation are triply degenerate. So subscript U and G indicates asymmetric and gyrate or symmetric gyrate with respect to a center of inversions. So symmetry and group theory, little bit I contributed here. So if you want to learn more and more related to symmetry and group theory, F.A. Cotton book is very important, and by Hall, these two books is very important. So I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.